Okay, this is the first of 3 videos going over section 2.6, and we're going to be looking at moments and center of mass. So first we'll look at a moment about a point. And that's going to be the mass times the distance from that point. So let's say that we have a point P, and then there is a mass of 3 kilograms that is 3 meters away. So the moment about that point is going to be 3 kilograms times the 3 meters, and so that's going to give us 9 kilogram meters. Let's say we have a seesaw, and on the left side is a 40 kilogram kid, and on the right side is a 50 kilogram kid. Okay, now the fulcrum is not dividing this in evenly right now. One side is 4 meters and the other side is 3 meters. So the moment would kind of give us an idea of which kid's going up, which kid is going down. So if the moment is negative, then the 40 kilogram kid will go down, 50 kilogram will go up. If the moment is positive, the 50 kilogram kid would go down, the 40 kilogram kid would go up. And if the moment was 0, then this would be perfectly balanced. We'd call this the equilibrium, and neither kid would go up or down. So we're going to go ahead and look at the moment. And so on the left-hand side we'll say that's the negative direction. So we'll say negative 40 times 4 meters plus 50 times 3 meters, and that's going to give us negative 10 kilogram meters. And so we can think of the 40 kilogram kid's going to go down and the 50 kilogram kid is going to go up. So let's see if we can balance this. So we're going to move the fulcrum. So what we're going to do is we're going to call the distance from the 50 kilogram kid to the fulcrum, we'll call that x. So then 7 minus x would be the distance from the 40 kilogram kid to the fulcrum. So we want the moment, which is going to be negative 40 for that left direction, 7 minus x plus 50 times x. We would like that to equal 0. Okay, so negative 280 plus 90x is equal to 0, so x is equal to 28 over 9. So just slightly under 3. Okay, so we're just going to move it just a little bit. 1/9 of a, what are we doing, meters? I don't know. Yeah, we're doing meters. So 1/9 of a meter to the right, and that would balance this. Okay, so now we have a balanced system there, and the equilibrium is going to be when your moment is going to be 0. Okay, so our equilibrium happens when the distance between the 50 kilogram kid and the fulcrum is 28 over 9. Okay, so let's go ahead and move along. All right, so a moment about the origin. And sometimes they'll do like an m sub 0. So that would be m sub 0, and then however many masses you have and their distance from the origin. So mass 1, x1, mass 2, x2, all the way out to the nth one. Okay. If your mass, so usually it's the origin, so we can call it m sub 0. If the mass, the moment about the origin is 0, then we're at equilibrium, or we can say the system is balanced, or is at equilibrium. The center of mass is the relocation of the origin, and that'll make the system at equilibrium. Okay. So center of mass is going to be the sum of all the moments divided by the sum of all their individual masses. So that's the sum of the moments divided by the total mass of the system. Okay, so let's go ahead and do an example of this. So we're going to find the center of mass. And we have a couple of point masses lying on the x-axis. Okay, the first one has a mass of 1. Mass 1 has a mass of 6, and the location is x1 equals -5. So there it is, mass of 6. The second mass we're going to look at is a mass of 3, and that's going to be located at x equals 1. And then the third mass is of mass 5, and the location of 3. Okay, and we're going to find the center of mass. So the center of mass is add up all the moments about the origin, and then divide by the mass of the system. So that's going to be 6 times -5 plus 3 times 1 plus 5 times 3, all over 6 plus 3 plus 5. So it's going to be -12 over 14. And so it's a negative, so it's going to be, if we had the fulcrum at the 0, this thing's going to tilt to the left. So the center of mass would be -6 over 7. So that's where we would relocate the fulcrum so that we would have equilibrium. Okay. All right, so center of mass, x bar is equal to -6 over 7. Okay. We'll also look at finding the center of mass in a two-dimensional system, so on the xy plane. So the moment of mass in a two-dimensional system, let's go ahead and let mass 1, mass 2, all the way out to mass n be located at points x1, y1, x2, y2, all the way out to xn, yn. All right, so the moment about the y-axis is, looks like it says it's m sub y. It's going to be sum I equals 1 to n, m sub I, x sub I. Okay, and so this might seem a little bit counterintuitive, but, the x is going to tell you the distance from the y-axis. And so the moment about the y-axis is going to be the mass, and then times its distance from the y-axis. And so it's actually going to be m sub I, x sub I, instead of m sub I, y sub I. So you got to be a little bit careful there. And then likewise, if we're talking about the distance to the x-axis, that's actually going to be determined by y. So they might seem backwards in some respect. All right. So the moment about the x-axis, and we call it m sub x, is going to be the sum I equals 1 to n, m sub I, y sub I. Your center of mass, this will be x bar, y bar. Okay, and so that's going to be m sub y over m divided by m sub x over the total mass of the system. M is equal to the sum I equals 1 to n of m sub I. All right, so let's go ahead and do an example of this. So we're going to find the center of mass, and our first mass 1, is going to be a mass of 10, located at 1, 3. Mass 2 is going to be a mass of 6, located at -2 and -5. Mass 3 is going to be a mass of 15 at 0 and -1. So we can go ahead and plot these just to see where they're at. Mass 10, mass 6, and mass 15. M sub y is going to be the moments about the the x-axis. Or actually, not moments about the x-axis. They would be moments about the origin. Okay, and m sub x. And that's how we defined it. Okay. Your center of mass is going to be the x bar, y bar, which is equal to m sub y over m, comma m sub x over m. So -2 and -15, but we do need to find the mass of the whole system. So mass of the whole system is 10 plus 6 plus 15. I think that's going to be 31. Okay. And so that locates the center of mass a little bit below the, just a little bit below the x-axis, slightly to the left, a little bit below it. So pretty close to the origin. And so that would be where we would relocate the origin so that this is balanced. Okay. Alrighty, so that's it for this video. We'll see you next time.